All right, let's start with angles first. I think the angles are the easiest because these two triangles are separated. So when I name an angle, how many letters do I need to use to name an angle when they're separated like this? Just one, right? And so, I mean, it's not wrong to name this LNM, but I can just call it angle N, right? I don't have to use three letters. Unless there's two angles at the same angle, I don't need to use three letters to name it. Okay, so let's start with angle N, okay? The only reason I'm starting with angle N is because it has one marking, right? It's the first angle that's marked. Angle N would be congruent to which angle? R, okay? And then angle L, I choose angle L because it has two markings, right? I'm just going 1, 2, 3. That's all I'm doing here. Angle L has two markings. So then I look over here at this triangle, and I look for the one that has two markings. It's got to be S. And finally, angle M is congruent to angle T. Okay? It's as simple as that. What parts have exactly the same markings? And if they're all marked the same, then that's pretty straightforward. What goes with what, okay? Sides are very similar, but when I name a side, how many letters do I have to use? 2, okay? So I'm going to start with the one that has one marking. Do I call this one ST or do I call it TS? Doesn't matter, okay? It does not matter. ST and TS are the same thing. So we'll go ST. What side is ST going to match with? Okay. This has one tick mark on it, right? One marking. So we're looking at the other one that has one marking. So ST and LM are congruent. And when you name a side, I don't care if you call it LM or ML. Okay, order doesn't matter for sides. The one time it does matter is when we do the triangle, which we'll do here last. Okay, then I go to the two markings. NM is congruent to RT. And finally, NL is congruent to SR. Three pairs of sides, three pairs of angles. We did that very early on in the chapter, where when we tried to prove triangles congruent, we had to know all 6 pieces were congruent. We don't have to do that anymore, okay? We're going to keep adding different types of theorems that we can use to prove triangles congruent. The only one we know right now is side angle side. Okay, when I do the triangle congruent statement, the first triangle that I name, I can use whatever order, whatever triangle I want, okay? So I'm going to start with this one up here. Okay, if you wanted to start with this guy down here, you could. But I'm going to be really specific about the order that I go in so it makes it easier. 1, 2, 3. Those are the markings that they have. So I'm going to go NLM. So I'm going to say triangle NLM. The reason I'm trying to be really specific about the way I go about it is because when I name this triangle now, I have to match up the corresponding pieces. We also could use this, but you're not always going to do this, right? You're not always going to list out all the sides and all the angles. So if I just look at the picture then, I could say N matches with R. So R has to come first, okay? A lot of you didn't pay attention yesterday to the order that you put your statement in, okay? N and R must be the same spot in the statement. Second one is L. L has 2 markings. S has 2 markings. And then finally, T. M should match with T. Okay? Now, it doesn't necessarily have to be in that order, but like yesterday on the quiz, we gave you this part first, so there was only one way to write this. Okay? And you had to match up which ones go with N, L, and M. But if I ask you to write the entire statement out, then I could go the opposite direction. I could go MLN and TSR, okay? And that would be a correct statement as well. So there's a lot of different ways that I could write that congruent statement. Okay? Any questions about any of that stuff? Okay, here is one I want to talk about. And, well, today we are doing a second theorem. Today our theorem is side, side, side. Okay? Side, side, side. What do you think we're going to be proving today? What three pieces are we going to have? All three sides. Okay? So we don't necessarily have to have an angle. So the side, side, side congruence theorem says if all three sides are marked as congruent or known to be congruent, I don't need to know anything about the angles. I know that these two triangles are congruent. So do I still have three pieces? Yeah, okay. But it's a different three pieces. It's not an angle. It's not side, angle, side. Now it's all three sides. So today what I want to get to the point of is proving that all three sides are congruent. Some of that information will be provided. Are there any other pieces that we can use to get us where we need to be? Okay. I will also say this. If the problem says write a proof, then I want to see a two-column proof. On the quiz yesterday, I told you that I think it was 7 and 8. You didn't have to write a proof. You could just provide me some statements. The very last one, it said write a proof. And so I told you we wanted a two-column proof for that. Some people didn't do it as a two-column proof. So if it says write a proof, do it as a two-column proof. That's the way we're going to do proofs if we do proofs, okay? So here we go. First statement we always know is given. KL is congruent to NL. KM is congruent to NM. And I can put all of that on statement 1 because all of that is given. It's also marked on the picture, okay? Sometimes it's marked, sometimes it's given, sometimes it's both. This time it's given to us and it's marked on the picture. Okay? We don't have any angles here marked, but is there something else that I can prove? Is there something else that I know about this picture as the way that it's drawn? Okay, how come? Yeah, okay. LM is congruent to LM by the reflexive property. Okay, and here's what I want you guys to understand. If I were to separate these two triangles, this one's LM, this one is LM. Okay, we're talking about two completely different triangles, right? Right now they share a side. So we know that side is the same because it's exactly the same side. LM and LM are exactly the same side. If I were to separate those two triangles, I'm trying to prove why this triangle and this triangle are exactly the same. Okay, and that's one of the ways I'm going to get there. I already know that these two sides are the same. I already know that these two are the same. So as I look at the pieces, do we have three pieces? Yeah, okay. What three pieces do we have here? All three sides, okay? So here's what we're going to do. For this statement right here, don't overthink it, right? You don't have to make up your own statement right here because they already give me a statement to use. This is what we're trying to prove. Triangle KLM is congruent to triangle NLM by side, side, side. Hey, right now these proofs aren't going to be 7, 8-step proofs, right? You have to tell me the given. The given is already provided to us. Step 1 is already done for us. We had to have some kind of link to get to here, okay? This statement was already provided. So all I really got to do in this case is come up with step 2 and then say why. Okay? That's all I'm really coming up with. Everything else is pretty much given to us. I also had some people yesterday trying to prove why these two were congruent. I don't have to prove why these two are congruent. All I have to say is They told me they're congruent, right? You don't have to prove to me why they're congruent. If they're marked, we know they're congruent, especially because they told me that over there. Bryson, let's be quiet, please. Okay, let's go to the next page. You can write this, or you can just pay attention. Okay, if I gave you two triangles like this, and I ask you, are these triangles congruent? Yesterday on the quiz, we said, identify the pieces that are not already marked, and then tell me, are they congruent or not, okay? There was a big old long sentence, but I don't think sometimes we don't read directions very well, or we just kind of get lazy and we don't do everything we need to do, okay? But as of right now, how many pieces are marked? Two. How many pieces do we need in order to prove these triangles are congruent? Three, okay? So if I say this is A, B, C, and D, okay, is there another piece that I can prove congruent? Bryson, what do you think?
No.
Nothing else? Everybody agree with that?
BC is congruent to BC.
Okay, how come?
Reflexive.
Reflexive property, okay? And that is something that we have to say. Some of you marked it on your picture, okay? But how do we know that? We know that because they are the same side, okay? So the reason I can mark that on my picture is because of this statement right here. We can't just leave that statement out. We have to know why they're congruent, right? That's a really, really important part. Okay, it's not a given statement. It's not already given to us. It's not already marked. So we have to say something as to why those two sides are congruent. So therefore, are these two triangles congruent now, Darston?
Yes.
How come? Nope, that's why the sides are congruent. So the sides are congruent because of the reflexive property. Why are the two triangles congruent? Core?
All three sides are the same.
Okay. Okay, not all three sides though.
Because it's midpoint. There's three.
Do we know C is the midpoint of AD?
No,
No. What three pieces do we know?
side angle side.
There we go. Yeah, side angle side. So now we could say triangle ABC is congruent to triangle DBC by side angle side. Okay? Don't take shortcuts is what I'm trying to say. We've got to provide information to get us to where we need to be. Okay? And that is not changing, guys. Okay? We are going to continue to do this for the next couple of weeks. Whether you want to hear that or not, it's the truth, okay? So we've got to be able to write these statements out better. And we got to provide information. We're not just going to be able to just say, yeah, because looks like it, right? That's not a good reason. We got to be able to provide information to back up what we do. And the more that we do, we're going to have more ways to prove triangles congruent. Right now, all we have is side angle side. I also had people trying to provide all kinds of information that they didn't need to do. I had people trying to tell me that A and D were congruent. We have no idea if A and D are congruent, okay? I had people telling me that AC and DC are congruent. Don't know that, right? If I did know that C was the midpoint of AD, then I could do that, right? We can't just make up things that we don't know anything about, okay? If I know information like C is the midpoint, then yeah, I can definitely say some information about that. We can only use what we know to get where we need to be.
Wouldn't C have to be the midpoint because of those two angles being equal and the sides being equal?
Yes, but do we have a theorem that we have talked about that yet? No. And so you are right, but since we have no way of proving that yet, then yes, but you are right. Okay, so that's what I really want to get at here, guys, is that I'm trying to get you to provide me more information, okay? And it's better to provide too much than not enough. There's some people yesterday that provided me too much, and I just like X'd out their stuff and said, we don't need that, okay? But it's better to provide too much than not enough. If I have enough to do side angle side, provide just the stuff for side angle side, and we can do that. Once again, write a proof. So what we want this to look like is a 2-column. Okay? First step's always what? Given. Okay? It's always given. You can separate this into 2 steps if you want to. And this is a little bit different than the last one because we're saying that all 4 of these sides are the same. So essentially, what kind of figure do we have here? Do we think it is? Probably a square, okay? We don't know if we have right angles yet or not, so we don't know for sure if it's a square because there's other 4-sided figures that don't necessarily have right angles. So we can't immediately jump to the square, but that's kind of what our initial thought is it kind of looks like a square, okay? Then we got this diagonal that goes from J to L across here. Okay, I'm trying to prove that triangle JKL, if you need to, highlight or label that, right? Or redraw it. JKL. Right? If you need to redraw it, redraw it. If you need to see the 2 triangles separately. And we're trying to prove that JKL is congruent to LMJ. Okay, right now, if I look at these 2 triangles, how many pieces do we know? 2, okay? I need one more piece. I got to have one more piece. Do we know any angles in this picture? No. We think this one is a right angle, but we don't know if it's a right angle. We don't have any way of proving that it's a right angle as of right now, okay? So even though it looks like a right, can I just assume that it's a right angle and say that it's a right angle? No, okay? It looks like it. We think it's a square, but we don't really know that for sure, okay? Unless it tells me some information that I can use to prove it, I don't know that for sure, okay? And it's not one of those things that you can just assume. Oh, it looks like it's a right angle, so we're going to call it a right angle. Okay? So as I look at these 2 triangles, is there something else that they share or that they have in common?
The center left line.
Okay? What would we call that one, Adrian?
I don't even know.
Huh?
Oh, the reflexive.
Okay, but what side would it be? What would we call that side? What side do they share?
L and J.
LJ, okay? So that's going to be our next statement. LJ is congruent to LJ. Would it be okay if I called it JL?
Yes.
Yes, okay? JL and LJ are the same side. Order does not matter when we talk about a segment, okay? And like he said, it is the reflexive property. So we're going to mark it now. Hey, do I now have 3 pieces? Yep. And is it the right 3 pieces? These 3 pieces are all 3 what? What kind of pieces do we know here? All 3 sides, okay? And so we now can say, and once again, you do not need to restate the proof statement. The proof statement is given to us at the very beginning. So just move it down here. Unless you really feel like writing your own statement, JKL is congruent to triangle LMJ. Because of side, side, side. Okay. as we look at these two benches that the football players are sitting on, explain why the bench with the diagonal support is stable while the one without the support can collapse. Why are these two different? Corey, what do you think?
The one with the diagonal support, it like makes a triangle, and the weight from the top point of the triangle gets sent out to the edges and the frame and the ground, so it relieves some of the tension from the top.
Yeah, that's exactly right, okay? And so what these two have in common is these two form congruent triangles, right? Basically like what we just did on that last one. This common triangle provides the support that makes these two triangles the same, okay? If I don't put that support and I have a bench like that, what's gonna end up happening to that bench? It's gonna start leaning one way or the other, right? It doesn't have that brace, it doesn't have that support. So that support, that beam right here, provides the support that these two legs are gonna move, okay? They're gonna be linked together. And so you can say this a lot of different ways. I would say something like this. The bench,
That wasn't me.
I just hear a lot of talking going on in the back, so I'm thinking that we're leaning towards moving for that whole back row, because we do a lot of talking back there. So either things are gonna, somebody was, okay? Everybody tells me it wasn't them. Somebody was, okay? So we just gotta knock out the talking, okay? We'll see about that. Bench with diagonal support forms a triangle with fixed side links. Which makes that bench stable. The bench without the support, you could make all different kinds of quadrilaterals. It could end up being like a parallelogram, and it could like sway back and forth because it doesn't have that support, okay? And we don't have those congruent triangles that's forming that, okay? So if you might say, well, where does triangle congruence ever come into anything that I'm ever gonna use? That is a situation where this provides the strength and support for that bench, okay? There's reasons why we would put that beam across there. It's not just because it looks good, right? It's providing that support, and that's all about triangle congruence. So what would you think about this one down here, if we were to put this together? Is this a stable picture or not? No? What would we need to make this more stable? Yeah, we need a diagonal going this way, or we need a diagonal going the other way, okay? If I wanted to do really good, I could do both, you're right. But we need some type of diagonal, right? We need a support brace. And that support brace would give us congruent triangles. It's going to keep that figure from leaning one way or the other, okay? And it doesn't matter which way we go with it, okay? We could go diagonal either way, or we could go both ways, but we do need some type of support to make that stable. Okay, we're going to continue talking about triangle congruence tomorrow. We'll have some more with 5-5. We're going to keep adding new statements as we go. And we're going to do a lot of things to kind of help you get practice doing these. I